Okay, great. Thanks very much, Jeff. So I'd just like to give you kind of an overview in terms of how the company came about, what problem we're solving, and also what we do on the technology side. And I hope that by the end of today, you'll have a good understanding of what we mean by Vmware storage and what it actually means from the product perspective. So as I mentioned earlier, so I ran engineering at VMware for quite a while. And what I saw at VMware, and actually after that, was that customers were getting a lot of benefits from virtualization on the server side, but storage was a huge pain. I'm sure you've actually seen that with customers. So typically, the environments are very complex, and they're very expensive to actually deploy virtual machines. And so one of the things about virtual machines, and you'll see this in the product demo, is there's actually the promise of making things simpler in a virtual environment. And that has not been achieved with current products. So what we decided to do was come up with a storage product that is specifically targeted for virtual environments. So just to understand, this would have seemed actually kind of a strange idea even a few years ago. But if you look at the market, and this is actually data that Paul Moritz, the CEO of VMware, presented a few years ago at VMworld, the majority of the market now is actually virtualized. So in 2009, for the first time, the number of virtual machines exceeded the number of physical machines. So it's actually the case that the physical machines are actually the minority. And so that if that was the case, then you would actually design a product that was for virtual machines rather than for physical machines. And that you'll see in the product. So the other thing was that storage is hard, okay, and we'll go through a lot of the stuff that's hard in storage today. But you could have a great idea, and it would be very difficult to implement it unless there were some very, very significant technology changes. So the other thing that we're taking advantage of, and I'm sure you've heard it many, many times over the last few days, is Flash. And we'll actually, Flash completely changes the way that you actually build a storage system. We'll actually go into a lot of detail in terms of how we use Flash within our system. And so it's the combination of those two things that actually defines what Tintri is. So two huge technology trends, virtualization and Flash, both occurring at the same time. Okay, so let's actually look at the problem again that we're solving, which is how would you build a storage system for virtual environments, okay? So the first thing that you would do is, well, we'll build a Flash file system. We'll build a file system that is oriented around Flash, that doesn't have the same set of assumptions that you had in disk-based systems. And again, we'll go into detail on this. Our belief is that in order to be efficient, you actually want to build a file system that, of course, is built for Flash, but that's economic. And in doing that, there's some data that you're actually going to store on disk. And Ed and Mark will go into a lot of detail on that kind of data. So you don't want to store things like snapshots. You don't want to store cold data in Flash. It's not economic to do that, even with techniques like deduplication and compression. So next. Okay, so basically, if you build a Flash file system, then you can address the issue of performance for VMs. Okay, so that's one aspect of what we're going to talk about and show today. So you can do cost-effective IOPS. You also, within our environment, we treat Flash as first class, so it's not a cache. We'll go into detail on that. And in doing that, you can actually build something that can lower the cost per workload. And that's one of the things that's going to be important in what you see today. So it's not about dollars per IOP necessarily, or dollars per gigabyte. It's actually about dollars per VM or dollars per workload. And that's going to be the important economic metric. So next. Okay,
The second aspect, and this you're really going to see in the demo, is the Vmware file system. Okay, so within a traditional storage system, you of course are familiar with LUNs and volumes and SAN and NAS, and though there's a mismatch there between the objects that are significant in a virtual environment. And again, that'll be very clear in the demo. We support virtual machines and virtual disks as the fundamental objects of our system. Okay, so we define snapshots on virtual machines, we define cloning on virtual machines, we'll have replication on a virtual machine basis. And again, you'll see that very clearly in the demo. It doesn't look like conventional storage. So in terms of, again, the two pain points that people see, there's the performance and efficiency aspect, which is addressed by Flash, and then the Vmware file system, which addresses the complexity issues, but also, as we'll see, allows you to do things at the right granularity, which means that you can be more efficient in terms of how you actually perform operations like snapshotting and cloning. Sure.
Is the Vmware file system, is that VMware aware file system rather than Hyper-V or?
No, so it's actually, that's a very good question. So it's actually very definitely hypervisor agnostic. Okay. So we've explicitly designed things so we're not tied in to VMware. VMware has the majority of the market today, but we will be supporting additional hypervisors in the future. Okay, so again, combination, if you come away with two things, a lot of interesting technology on the file system, the Flash file system side, and the VMware file system. Okay, to David. Okay, so let's actually go to the next slide. So we're actually going to talk about now what VMware storage means and how it relates to what's hard in storage. Because one of the things, you could have a great idea for a storage system, but if you don't do the basics, then it's just not going to work. Okay, so we'll go into some detail on this with Ed and Mark's presentation. But the fundamentals on storage are about reliability. They're about doing high availability, adequately dealing with NVRAM, doing data integrity. If you don't do these things, you're not a storage system. Okay, so let's go up the next layer. So the next layer is actually how you deal with Flash. Okay, and this is, in order to do this, in order to be efficient, you want to be dealing with MLC Flash. You want to be dealing with commodity Flash. You also want to have compression and deduplication. We'll go into some detail on that. And you also, in order to deal with the particular characteristics of Flash, you want to build a file system that is specifically for that environment. And we will, a log structured file system, we'll go into some detail on that as well. So we're also going to talk about the way that some of the data we will actually store on disk. And in doing that, we actually do working set analysis. So we actually decide whether the data for a particular VM actually needs to sit in Flash or if it could be pushed out to disk. And again, we'll go into a lot of technical detail on that. So next. So this is all great. So in order to build a storage system, you need to do all of these. We're going to talk about how we do this. But where a lot of the value is, this isn't enough. For a virtual environment, you actually want to do something where you are VM aware, where the fundamental objects in the system are virtual machines and virtual disks. And you'll see this in the UI. And that's not just in the UI, just to emphasize that. It's right down to the file system. This is a file system that is designed for storing virtual machines. So if you consider an analogy in terms of other products, the data domain was a file system that was designed for storing backup. Isilon is a storage system, a file system that was designed for storing large data. Here we have a file system that's designed for storing virtual machines and the particular characteristics of virtual machines, which we'll go into some detail on. So within our system, and you'll see this in the demo, the operations are performed on a VM level. So you'll see cloning at a VM level, you'll see snapshotting at a VM level, you'll see the ability to be able to drill down at a VM level. So no LUNs, no volumes, none of the traditional storage concepts. But again, you still need to do all this stuff. You still need to do all this very complex functionality for reliability and for dealing with flash. And of course, performance is a significant deal. So again, what you're going to hear about is flash file system, and you're going to hear about Vmware file system as well. So I'll turn it over now to Ed and Mark. Any questions before I do that?
This is good. Great point.
Yeah.
I'll throw one out.
Sure.
What is the rough schedule for supporting other hypervisors?